So here in this video we are going to see exercise 7.4 under integration, that is under your chapter 7 we are going to see exercise 7.4. So before going on to this exercise 7.4 we need to know certain formulas under this exercise 7.4 here, which is needed to solve the problems under exercise 7.4. So what is the first question you have? Integral of 1 by x squared minus a squared dx. What is it equal to here? It is equal to 1 by 2a log of modulus of x minus a divided by x plus a plus a constant. The proof for this is not needed here, so I am just giving you the formulas alone in this case. Okay, so it's 1 by 2a log of mod x minus a by x plus a plus a constant. What's the next one you get? Integral of 1 by a squared minus x squared dx. What is it equal to? 1 by 2a log into modulus of a plus x divided by a minus x plus a constant. Okay. Next is integral of 1 by x squared plus a squared dx. What will I have? It's 1 by a into tan inverse of x by a. This already we have done it, a similar one. What was it? Integral of dx divided by 1 plus x squared is equal to, you had it as tan inverse of x you had. The same way here you had, instead of a you had 1. So 1 by 1 is nothing but equal to 1. So you just had it as tan inverse of x. But here if it is x squared plus a squared, you have it as 1 by a into tan inverse of x by a plus a constant. Okay. Now here the next one. Integral of square root of 1 by square root of a squared minus x squared dx. What is it equal to here? It's equal to sine inverse of x by a you get. Okay. Now here fifth one, integral of 1 by square root of x squared minus a squared dx. What is it equal to here? It is equal to log of x plus square root of x squared minus a squared plus a constant. There's a difference between these two formulas. Here you have it as 1 by square root of a squared minus x squared. Here if you see, you have it as 1 by square root of x squared minus a squared. Both are not same. The reason you have the square root here, and moreover you have a negative sign in between here, so it's not the same. It is equal to log of mod x plus square root of x squared minus a squared plus a constant. What's the next one? 1 by square root of x squared plus a squared dx, which is equal to log of mod x plus square root of x squared plus a squared. So it's enough if you remember either one of these formulas here. Then in that case here it's easy for you to remember this. So once again here, okay, just for your reference here, what is 1 by x squared minus a squared? It is 1 by 2a log of mod x minus a by x plus a plus a constant. 1 by a squared minus x squared dx is what? It is equal to 1 by 2a log of mod of a plus x divided by a minus x plus a constant. The next one, it's integral of 1 by x squared plus a squared is equal to 1 by a into tan inverse of x by a plus a constant. The fourth one is integral of 1 by square root of a squared minus x squared dx is equal to sine inverse of x by a. And the fifth one, you have it as 1 by square root of x squared minus a squared dx is equal to log of mod x plus square root of x squared minus a squared. Now here it's integral of 1 by x square root of x squared plus a squared dx, which is equal to log of mod x plus square root of x squared plus a squared plus a constant. Okay. So here, keeping these formulas in mind, we'll go over to exercise 7.4. So exercise 7.4, any one of these 6 formulas only I will be using here, but not directly here. Okay. So here you'll have to simplify it a little, either by the method of substitution or by some other method. We'll have to simplify the given algebraic or the trigonometric functions and then apply the formula. Okay. So exercise 7.4, the first question. What have you got? Integral of 3x squared divided by x power 6 plus 1 dx. So in the previous exercise I had mentioned, if you get a rational function, first of all check if your differentiation of the denominator gives you the numerator. So now if you see, when you see it directly you will not get it, because what is differentiation of x power 6? That's nothing but 6x power 5 you get here. So it's not possible. So what I will do here is I equal to integral of 3x squared divided by, so this x power 6 I'll write it as x cube the whole square plus 1 dx. Okay, we write it as x cube plus 1 the whole square dx you have here. So what is the substitution you put here? Put t is equal to x cube. So what will I have? dt by dx is equal to 3x squared. So what is your dx equal to here? Dx is equal to dt divided by 3x squared. So I'll just substitute it here and then we'll see how we have got it. Okay. So I have substituted it here. It's integral of 3x squared divided by t squared plus 1, because what was the original integral you had? Integral of 3x squared divided by x cube, the whole squared plus 1. What was the substitution we had? It is t squared plus 1 into dt divided by 3x squared. So here it gets cancelled. You're left with integral of dt divided by t squared plus 1. As I mentioned in the starting of the exercise, what did I tell you actually here? Here in this case, you cannot integrate it straight away by the substitution method here. We'll just simplify it and we'll bring it to the standard form. What are the standard forms you have? Either integral of dx divided by x squared plus a squared, or square root of x squared plus a squared, or in the form of integral of dx divided by a squared minus x squared. So some standard form I'll have to bring it here. So what form I have brought it here? It's integral of dx divided by x squared plus a squared. That's a form you have here. So what is your x here? It's nothing but t. What is your a here? It's equal to 1. This can be written as 1 square. So what will I have the formula? It's 1 by a into tan inverse of x by a plus a constant you get here. So what is 1 by a here? You will have it as 1 by 1 into tan inverse of t, because in this case it's tan inverse of x by 1. So you will have it as t by 1, that's nothing but the same. Tan inverse of t plus a constant. So here what is the value of t here? T is equal to x cube. So you write it as tan inverse of x cube plus a constant. You understood here? So certain questions you can apply the formula directly. Certain other questions by the method of substitution, you will have to bring it to the standard form and then only we will have to apply the formula. Okay. What's the second question you get? Integral of 1 by square root of 1 plus 4x squared dx. So here I give this integral name to be equal to I. That's why I write it as I equal to. So here you have it as 1 by square root of. What is the standard form you have with plus actually here? It is either a squared plus x squared or x squared plus a squared. Whatever it is, the order changes. But here if you see, you don't have x squared, you have it as 4x squared. So this coefficient of x squared must be made as 1. So what can I do here actually here? I can just take this outside. 1 by square root of this 4 is taken outside. You are left with x squared plus 1 by 4 dx. Now here 1 by square root of 4. What can I write here? It's 1 by 2 integral of dx divided by square root of x squared plus 1 by 2 the whole squared you get. Okay. So what is integral of dx divided by square root of x squared plus a squared? What is the formula you get actually here? It is equal to log of mod x plus square root of x squared plus a squared. This is the formula you have here. So according to this formula, you have this 1 by 2 here. So I have taken 1 by 2 log into modulus of what is this? It's nothing but x plus square root of x squared plus 1 by 4 plus a constant. Is it clear? So here again the standard form, it means that bringing it to this form, not only by substitution. See here always the coefficient of x squared must be 1 when I bring it to the standard form. Is it clear? Yes. Now the third question, it's integral of 1 by square root of 2 minus x the whole squared plus 1. So 1 by square root of 2 minus x the whole squared plus 1. Here if you see what have you got actually here, it's nothing but in the place of x you have it as x squared plus a squared. This is what you have here. So if you have it as x squared plus a squared, it's nothing but square root of 1 by square root of x squared plus a squared. So how do I write here? It is equal to log of mod of 2 minus x plus square root of 2 minus x the whole squared plus 1. So straight away I can apply this formula here. Is it clear? Okay. Now here the fourth question. So what's the fourth question you have? It's integral of 1 by square root of 9 minus 25x squared. This is what you have here. So what form is it? First you try to identify it as of what form. It is square root of, when it is minus you will have to be a little careful because it is a squared. This is your constant. Constant we will take it as a squared minus x squared. So what is integral of square root of a squared minus x squared? It is equal to 1 by a into sine inverse of x by a. This is the formula you have here. 1 by a sine inverse of x by a. So I equal to integral of, so here what will I do? I told you the coefficient of x squared must be 1. When I take square root of 25 outside, you are left with 1 by 5 into square root of 9 by 25 minus x square dx you get. So what is this equal to here? It's 1 by 5 into integral of 1 by square root of 3 by 5 the whole squared minus x squared dx you get. So is it of this form, square root of a squared minus x squared? So when I apply the formula, what will I get? 1 by 5 into sine inverse of x by a. So your x is nothing but x. What is your a? Don't write it as a squared along with the square. You will have to write only a there. So you will write it as 3 by 5. So when this goes to the numerator, you will have it as 1 by 5 sine inverse of 5x by 3 plus a constant. Yes. Okay, now we'll start with the fifth question here. What's the fifth question you get? Integral of 3x divided by 1 plus 2x power 4 dx here. Okay, so seeing it as it is, again if you have a rational function here, in this case a direct substitution is not applicable here. Okay, so I'll have to bring it to the standard form. So see how I will bring it to the standard form. Always this coefficient of x, whatever is in the denominator, must be 1. So I'll just take 2 into, so here you will have it as 1 by 2 plus x squared the whole squared, because this x power 4 can be written as x squared the whole squared you get here. Now when I differentiate x squared, what will you get? You will get 2x you will have there. That's nothing but you have the numerator. So what will I do here? Put t is equal to x squared. You will get dt by dx is equal to 2x. So what is your dx equal to here? It is equal to dt divided by 2x. Now here what will happen? Take 3 by 2 common. This is a constant only, so I've just taken 3 by 2 here. Integral of x divided by 1 by 2 plus t squared into, what is your dx here? It's nothing but dt divided by 2x you get. So here what happens? Your x and x gets cancelled. You have this 1 by 2 here. When I take this 1 by 2 outside, you're left with 3 by 4 integral of dt divided by 1 by 2 plus t squared. Is it clear? So have I brought it to the standard form? What standard form you have here? Integral of dx divided by a squared plus x squared or x squared plus a squared. Okay, even if you don't get a perfect square, you have to write it as a perfect square. See how I've written it as a perfect square here. It's 3 by 4 dt divided by t squared. This can be written as 1 by root 2 the whole square. So you're supposed to write it like this. So what is this actually here? It's nothing but your a. Your a is equal to 1 by root 2. So what is the formula for this? It's equal to 1 by a into tan inverse of x by a you have here. So what is it actually here? You have 3 by 4, okay, into 1 by a. So you have it as 1 by root 2 into tan inverse of, what is it here? T by 1 by root 2 plus a constant. So here this goes to the numerator and this also goes to the numerator. You are left with 3 root 2 divided by 4 into tan inverse of root 2 into x squared plus a constant. Is it clear? Okay. So see how I brought it to the standard form by the method of substitution. The previous one we integrated it itself by the method of substitution. Here it's not like that. We are bringing it to the standard form by the method of substitution and then I am applying the formula. Any one of the 6 formulas are what I mentioned in the beginning. Okay. Now the sixth one is also a similar one. You have it as x squared by 1 minus x power 6. So can you think of any option here? How can I write this x power 6 as? Yeah. So this one I can write it as x cube the whole square. You may ask me, why is that I cannot write it as x square the whole cube? I do not have any standard formula for this one here. First thing. The next thing, when I differentiate x squared, I will get only 2x. But when I differentiate x cube, I will get 3x squared. You understood? So these are the two reasons I write it as x cube the whole square. So I equal to x squared by 1 minus x cube the whole square. So what's the substitution you put here? T is equal to x cube. What is your dt by dx equal to here? 3x squared. So you will get dx is equal to dt divided by 3x squared you have here. So I equal to integral of, what will I get here actually here? It is x squared divided by 1 minus t squared into dt divided by 3x squared. So here it gets cancelled. Okay. So what's the formula? What is the standard form you have here? I've taken this 1 by 3 outside. So you're left with integral of dx divided by a squared minus x squared. This is the formula, a squared minus x squared. There are two formulas, don't confuse with it. One is a squared minus x squared and the other one is x squared minus a squared. So here this is equal to 1 by 2a you have here, okay, into log of mod a plus 6 divided by a minus 6. This is the formula. Okay, so again I'm telling you, don't confuse between a squared minus x squared and x squared minus a squared, because both have got different formulas here. So 1 by 2a, what's the value of a here? It's nothing but 1. 1 by 3 into 1 by 2, a you get, a is equal to 1. Okay, integral of 1 by, what will I get here? It's nothing but 1 minus t squared you get here. Okay, so here if you see, after integrating it, you have it as 1 by 3 into 1 by 2, that's nothing but 1 by 6 log of a plus 6, what will I get? 1 plus t by 1 minus t plus a constant. What's the value of t you get here? 1 by 6 log of mod 1 plus x cube divided by 1 minus x cube plus a constant. Is it clear? Yes. The seventh question. Integral of x minus 1 divided by square root of x squared minus 1 you have here. Okay. Now however, I think this is already in the standard form, because what's the denominator you get here? It is x squared minus a squared. So what is integral of square root of 1 by square root of x squared minus a squared dx? What will I get here? The formula is nothing but equal to log of mod x plus square root of x squared minus a squared plus a constant you have. This is the formula. But the numerator I have it as x minus 1. So I'll have to think of a method. What I'm going to do here is I'm going to split it as two fractions here. I equal to x minus 1 by square root of x squared minus 1 dx, which is equal to x by square root of x squared minus 1 dx minus integral of 1 by square root of x squared minus 1 dx you get. So you get two integrands here that I have named it as I1 minus I2. Okay. So first we'll integrate this. I1 equal to integral of x divided by square root of x squared minus 1. So what will you put? Put t equal to x squared minus 1, because how will I integrate it here? It's not in the standard form actually here, because in the numerator you have x. So here I'll have to go back to our previous exercise method. What was it? By substitution. So put t equal to x squared minus 1, dt by dx is equal to 2x. So you will get dx is equal to dt divided by 2x you have here. So I1 is equal to, what will I get? Integral of x divided by root t into dt divided by 2x. Your x and x gets cancelled here, which is equal to 1 by 2 integral of 1 by root t into dt you get. So taking it to the numerator, you will have it as 1 by 2 integral of t power minus 1 by 2 dt is what you have here. When I integrate this one, it's 1 by 2 into t power half divided by half plus a constant. So what happens here? Your half and half, it gets cancelled. What is the value of t here? It is equal to x squared minus 1. So you will have it as square root of x squared minus 1 plus a constant. This is what you have here. So I have integrated the first integrand. Now coming over to the second integrand, what have you got? I2 is equal to integral of 1 by square root of x squared minus 1 dx. So straight away the formula. So I mentioned what's the formula in the beginning of the question itself here. What is it? It's log of mod x plus square root of x squared minus a squared. So what will I have here? In the place of a squared, you have just 1. So I can write it as log of mod x plus square root of x squared minus 1 plus a constant. Is it clear? Okay. Now here the next one, eighth one. What's the eighth one you get? It's x squared divided by x power 6 plus a power 6. So by now we have done a similar question here, not exactly a similar one. So I've done rational functions like this also here. Now here in this case, rational ones here. So what is it actually here? I cannot use a substitution directly, but I can, by using the substitution only, I'll have to simplify this. How do I write this x power 6 as? Yeah. So I will write this as x cube the whole square. This is how we are going to proceed here. So how do I proceed? I is equal to integral of x squared divided by square root of x cube the whole square plus a power 6 dx you get. So you put t is equal to x cube, dt by dx is equal to 3x squared. So what is your dx equal to here? dt divided by 3x squared is what you have here. Got it? Now what's your I equal to here? I equal to integral of x squared divided by square root of This is nothing but t squared plus I write this also as a cube the whole squared into dt divided by 3x squared. So it gets cancelled. You're left with 1 by 3 into 1 divided by square root of t squared plus what will I get here? A cube the whole squared. So what formula I'll have to use here? Just remind yourself what's the formula I will use here? Integral of dx divided by square root of x squared plus a squared. So what's the formula you have here? Yeah, it is equal to log of mod x plus square root of x squared plus a squared. So you have it as 1 by 3 log of, I told you, you will have it as log of mod x plus square root of x squared plus a squared, I told you. So instead of x you have t there, t squared. So you will write it as t plus square root of t squared plus a power 6 because there you have a cube the whole squared plus a constant. So what's the value of t here? It is x cube. Here again when I substitute it as square root of x power 6 plus a power 6 plus a constant. This is what you have here. Got it? Yes. Now the 9th question, it's integral of secant squared x divided by square root of tan squared x plus 4. Okay, this is what you have here. So your I equal to, so till now we saw all with algebraic ones, here we are seeing with trigonometric. So once again here, what did I tell you actually here? You by using the method of substitution, we'll see if we can bring it to the standard form. When I differentiate tan, what will you get here? It's secant squared. Yes, that's the thing, that's all. So what will I do here? Put t is equal to tan x. What will I have? dt by dx is equal to secant squared x. So you will get your dx to be equal to dt divided by secant squared x. What is your I equal to? Integral of secant squared x divided by square root of your t is equal to tan. So I will write it as t squared plus 2 squared into dt divided by secant squared x. It gets cancelled, which is equal to integral of dt divided by square root of t squared plus 2 squared. So what will I have here? What is the formula I will be using in this case? It is integral of dx divided by square root of x squared plus a squared. What will I have here? It is equal to log of modulus of x plus square root of x squared plus a squared. This is the formula you have here. So using that formula, we'll write it as log of mod t plus square root of t squared plus 4 plus a constant. So what's the value of t? What will I get here? It's nothing but tan x plus square root of tan squared x plus 4 plus a constant. Is it clear? Yes.